In the previous lesson, we have talked about the basic form of a hyperbolic function, which was given as y is equal to a over x plus q. In this lesson, we'll be talking about the hyperbola of the form y is equal to a over x minus p plus q. So, the major difference between this graph and this graph is that this one is the first graph and this one is the one that is being shifted to form the new one. Okay, so initially, before we do anything, we have this graph, okay, and this one will arise from this one. This means that we're going to shift this one to form this one. Let me give you an example. Suppose we have a graph that is given as y is equal to 3 over x. Let's say plus 1. So what we do is that this graph is given in the form y is equal to a over x plus q. Check the value of q. Q has to do with the vertical shifting up or down. So if you can say now we now have y is equal to 3 over x plus 3. What can you say happened? Okay, how did we move from 1 to 3? We added 2. This means we went up. When we plus, we go up. When we minus, we go down. So this graph, this one here, is this one when it has underwent up by 2. I hope it is clear. So, to check whether how much did it shift by vertically, check the value of q. Q has to do more with the vertical shifting. Okay? So, if it becomes negative, it means we have went down. I hope it is clear. Now let's talk about the horizontal shifting. Suppose we have the graph y is equal to 4 over x. And we have the graph y is equal to 4 over x minus 2. And the graph of y is equal to 4 over x plus 2. So, what can you say about this graph in relation to this one? This one is the mother graph, the first case, and this one is the second case, the transformed one. Okay? So now check. We moved from x here to x minus 2. This means we minus 2 from this graph to get this one. As long as we minus a number from x, we go to the right instead of left. Okay, most of you will say that no, the negative is to the left, but no. When we minus on the value of x, we go to the right. And when we add on the value of x, we go to the left. So these are very essential for exam purpose. We've been given a graph. Now let's mix the two transformations. We're going to say that y is equal to 3 over x plus 4. Now let's have y is equal to 3 over x plus 3 plus 2. So now, can you compare the two graphs, graph 1 and graph 2? Tell us how did the graph 1 move to form graph 2. Okay, so now we're going to check the value of q. This will tell us about the vertical shifting, the shifting of up and down. And we said that positive is when we go up, negative is when we go down. So, how did we move from 4 to 2? We minus 2. This means the graph went 2 units down. Okay, so now we are here. Now we are here on x and x plus 3. How did we move from x to x plus 3? We added 3. So what can we say? We said that if it goes to the right, we minus. If it goes to the left, we add. So from x to x plus 3, well, we went this direction. This means we went 3 units left. Sometimes the examiner can say, give the transformation. Tell us how did this graph move to form this graph. Well, we have to say that it moved 2 units down and 3 units to the left. I hope it is clear. Make sure you are able to understand transformations. You are able to transform a graph. You are able to shift it. Even if they give you a graph itself, you must be able to shift each and every point. So now let's talk about the asymptote of the transformed graph. Okay, it's a different story after all. So suppose you have the graph y is equal to 4 over x 4 over x minus 2 plus 3. What is the asymptote? Equations of the asymptotes is given as y is equal to q. This means that y is equal to 3. That's the asymptote. It's where the graph is undefined. What about the x asymptote? To get the x asymptote, we're going to say that x minus 2 is equal to 0. This is the x minus 2. And then at the end, we can say that x is equal to 2. This is the asymptote. How much does x have to be to make the equation be undefined? Well, we must have division by 0. How much do you have to add to minus 2 to have 0? You have to add 2. So to get the asymptote, the vertical asymptote, we must have x minus 2 is equal to 0. Okay, so the number which is here, if we see minus 2, know that the asymptote is actually x equal to positive 2. If you see that below you have 3 over x plus 4, the vertical asymptote is actually x is equal to minus 4 and not positive 4. This is the trick that you can use. Okay, minus 4 plus 4 is 0 and 3 over 0 is undefined. This means that the thing is undefined if x is equal to minus 4. I hope you understand. So to give the domain and the range, we're going to say that y is an element of real numbers. For the range, we're going to say that y is an element of real numbers. But y is not equal to q. What is q in this case? Let's see. Q is 3. But y is not equal to 3. To get the domain, we're going to say x is an element of real numbers. But x must not be equal to the asymptote, which is negative 4. I hope it is clear. So don't forget, the horizontal asymptote is given as y is equal to q. And the vertical asymptote is given as x is equal to. I hope it is clear. Feel free to ask in the comment section. But we'll do question papers at a later stage to be able to explain thoroughly these theories which we are learning here. Thank you for watching.